Hey guys, so tonight we're going to talk about section 12.2, which is chords and their arcs. So to begin this lesson, let's refer back to central angles. So here we have a circle. I'm going to have you draw this with me. Let's draw one central angle on the left. And let's name that angle A, B, and then C. And let's say I have another central angle in the picture. Let's also give it a name. Let's call it D, B, F. All right, so let's say I give you that these central angles are congruent. I'll just make up a number. Let's say they're 70 degrees each. Well, we can definitely figure out the measure of their minor arcs. Arc AC would also be 70, and same with arc DF, that would also be 70. So we could say that whenever you have congruent central angles, the arcs will also be congruent. So I'm going to put tick marks there. So let's write this down. If central angles are congruent, then their arcs are congruent. Now, I'm going to teach you guys something new that ties into this section 12.2. If we were to make a chord using the endpoints of the arc, so if I were to connect AC here and make a chord, and if I were also to connect D and F and make another chord, do you guys think those are going to be different lengths? No, they're going to be the same length because the arcs are the same. So not only are their arcs congruent, but we can also add their chords are congruent. So this is one of the big ideas behind today's lesson. We're going to see this a lot. So if central angles are congruent, then their arcs are congruent and their chords are congruent. All right, so let's take a look at an example. So for example 1, we have circle T and circle O, and it says circle T is congruent to circle O. We're going to write down what we can conclude about these circles. So if you notice, there's two central angles, one in circle T, one in circle O, and that red arc that I've given to you means that the angles are congruent. So if the angles are congruent, what else can we label as congruent? Well, we can start by saying the arcs are congruent. Now let's put a tick mark here, and let's jot this down. So we can say arc HS is congruent to arc DL. And what else could we say? Their chords are congruent, connecting H to S and D to L. So segment HS is congruent to segment DL. All right, let's take a look at example 2. Sometimes you do not have central angles in the picture, but if you have congruent chords or congruent arcs in the picture, you can still use this big idea. So example 2 says, what is the length of segment AB? So I'll put a little X here, that's what we're looking for. So if you look at this circle, we have two chords, AB and CD. I know that chord CD is 9 units long, but we're also given their arcs. And you'll notice that the arcs are congruent. They're both 155. So if the arcs are congruent, what do you think we could say about the chords? The chords are going to be congruent. It's that same big idea. So we can say x equals 9, or AB equals 9. Let's take a look at example 3. So we're trying to find the measure of arc AB. So I'll just put a little x here. And again, let's see what we have. Well, we have two chords. In the picture, we have chord BA. We also have chord CA. Okay. And you'll notice that the chords are congruent. So let's talk about their arcs. Well, the arc of chord BA is arc BA, which is the x, and the arc of chord CA is arc CA. And if my chords are congruent, what do we know about the arcs? The arcs are also going to be congruent. So if arc BA is called x, I can also call arc CA x. And then how do you think that's going to help us find the measure of arc AB? Well, if you notice, we were given that this very top arc is 100. And what do we know about a full circle? It's 360 degrees. So I can add up all the arcs that I have and equal them to 360. So we can have x plus 100 equals 360. So you'll have 2x plus 100 equals 360. Subtract the 100 to get 260. And then divide x is 130. So each of those arcs are going to be 130 degrees. Okay, and then let's take a look at example 4. We're trying to find the measure of arc TU. So I'll put a little x here. So let's see what we've been given. Well, we have a central angle, SQR, and we're given that it's 85 degrees. And you'll notice that I'm given two chords, SR and TU. And we're given that the chords are congruent. So if the chords are congruent, what can we say about the arcs? The arcs are also going to be congruent. So we can just figure out the measure of arc SR, then we automatically know the measure of arc TU. How do you guys think we'll find the measure of arc SR? We have that central angle. So whatever the central angle is, that is going to be the measure of the arc as well. So this is 85. So we automatically know x will also be 85 degrees. So the measure of arc TU is 85. Okay, so now we're going to expand on this big idea. I'm going to teach you guys 3 properties that all deal with the center of the circle. You do not have to memorize the number of these 3 properties. You just need to be familiar with the 3 properties. So let's take a look at property number 1. It says if 2 chords are equidistant and perpendicular to the center. So let's just start there. This property means you're going to have 2 chords. So if I look at this picture, I have 2 chords, A, B, and C. They're going to be equidistant to the center. That means the same distance to the center. Equal distance. So if you look here in the picture, you're given that the distance from this chord to O is the same as the distance from that chord to O, because there's little tick marks here. I'm just going to make up a number. Let's say they're both like 3 centimeters away from the center. Okay. But they're also going to be perpendicular to the center. So that just means they're making right angles to the center. So if you ever see this scenario, two chords are the same distance from the center, they're also perpendicular to the center, then we can conclude the chords are congruent. So if I were to take a look at my two chords, my first chord is AB, so I would say chord AB is congruent to chord CD. And then this uses that big idea that we just did on the last few slides. If the chords are congruent, then what can we say about their arcs? The arcs are congruent. So if I were to go back to the picture, the arc for the first chord is AB, and I'll put 3 tick marks there. It's going to be congruent with the other arc, which is CD. So this is just expanding on the big idea. Okay, so let's talk about something a little bit different. So this says, let's say you have a chord. So here I have a chord, CD, and it's just perpendicular to the center of the circle. So notice how it makes a little right angle with this segment that's going to the center of the circle. Anytime you have this scenario, then we're going to be able to say the chord gets bisected. And in case you don't remember, bisected means split in half. So this property says if I were to look at my chord, which was in green, it's going to get split in half. So the first part, CE, would be congruent to the second part, ED. And that's just a result of being perpendicular to the center. Now, let's kind of use this with that big idea. If my chord is being split in half, what do you think is going to happen to its arc? It's also going to get split in half. So the first part, which would be CA, would be congruent to the second part, which would be arc AD. So this is saying arc AC would be congruent to arc AD. Okay, and then there's just one more center property. So let's take a look at number 3. So this one says, if you have a segment that is a perpendicular bisector of a chord, okay, so it means I have two things. I have a segment and I have a chord, and one of them is a perpendicular bisector. So if I take a look here, my segment is going to be AB, and my chord that is being bisected is going to be CA. So if that segment is perpendicular to the chord, and it's also bisecting the chord, then we can say a few things about that segment. We can say the segment is a diameter. And I just want to include that whenever we have a diameter, it's going to pass through the center of the circle. So even though there's no center drawn here, I know that AB is going to pass through the center because that's the definition of a diameter. So I'm just going to also include that in the description here. So it is a diameter and contains the center of the circle. Okay, so basically for the rest of the notes, I'm just going to go through different examples that touch on each of these three properties. So my suggestion is take a look at these three properties, try to get familiar with them, try the next few examples on your own first. See if you can figure out which picture matches with which property, and then maybe pause the video, try the problems, and then replay the video and see if what you're doing matches up with what I'm doing. So for example 1, we are trying to solve for R. So R is this segment LK. R just stands for radius. We're just trying to find the radius of the circle. So analyze what we have been given in the picture. We actually have not been given too much. We've been given a chord, LM, and you'll notice that we've also been given that it's perpendicular to the center. So I have a chord that is perpendicular to the center. So which of those three center properties is this one talking about? This is talking about the second property. I'll just put a little number 2 here. And according to that second property, when this happens, the chord gets bisected, which means it's split in half. So I can actually label that chord LM is going to get split in half. Now we're given that the entire length of LM is 14. So when it's split in half, they're each going to be 7. So now that I know part of my chord is 7, how does that help us find R? Do you notice any shape that is inside of the circle? We have a right triangle. So if you have a right triangle and you have one missing side of the right triangle, how can we find the missing side? We can just use the Pythagorean theorem. So this would just be 7 squared plus 3 squared equals R squared. So let's go ahead and square everything. That's 49. This is 9. We're going to add them up to get 58. And then we're just going to take the square root. The instructions don't tell us to round. They don't tell us to put it in simplest form. I'm totally okay if you just leave it as the square root of 58. Okay, I'm going to have you try example 2. Maybe try it on your own, pause the video, come back and see if your work matches my work. So when you look at example 2 here, we're solving for y. So this time y is not a radius because it doesn't actually extend from the center all the way to the edge of the circle. But let's analyze what we've been given. Well, we've been given a chord, AF. And again, we've been given that it's perpendicular to the center. So again, you got to ask yourself, okay, which of those three center properties is this? This is also that second property. And as a result, the property says the chord gets bisected. So we can split that chord in half. So again, we're given that the entire chord is 22. So we can split it in half, make each of these 11. And do you guys notice a shape inside of a circle? Well, we have a right triangle. And we know that one side is 11, one side is y. We're missing that third side. But there has been a 15 that's been given to us. Do you think we can use that 15? Well, what does that 15 represent on the circle? It represents a radius. Now, segment AB is also a radius. So a radius from one side of a circle to the other side of a circle is not going to change. So we can technically transfer that 15 over to this radius that we're using on the right triangle. So now you guys can do Pythagorean theorem again. So this would be y squared plus 11 squared equals 15 squared. And you'll end up getting 121 and a 225. You're going to add them up. You're going to get 104, and then you can just take the square root of 104. All right, let's take a look at example 3. All right, we're trying to find the length of RS. So I'm going to put a little X here, or RS's. So again, let's analyze what we've been given. Okay, well, I've been given a chord, PR. We've also been given another chord, SR. So we've been given 2 chords. You'll notice that they're both perpendicular to the center, and you'll notice that they're both 9 units from the center. So you got to ask yourself, which of those 3 properties is this? This is that first property. So we learned that when you have 2 chords that are both the same distance from the center and they're perpendicular to the center, the chords are congruent and their arcs are congruent. So let's take a look at what we have here. My chords are going to be congruent. So if I take a look at my first chord, PR, I see that it's being split in half here. One half is 12 and a half. So the other half is going to be 12 and a half. So the total is going to be 25. So that's also going to be the length of SR, which is exactly what we're looking for. So that's our answer. All right, moving on to example 4. Example 4 is asking, is QS a diameter? And we need to explain. So again, let's analyze what we've been given. So we have a chord, PR, and it is perpendicular to the center, and it's been bisected. Okay. So we have a chord that is perpendicular to the center, and it's been bisected. So which of the 3 properties is this one describing? This is the third property. And as a result, QS is a diameter. Now it says explain, so we have to say why. So we'll say because of that third property, it is a perpendicular bisector of the chord. So that means it's a diameter. Okay, so example 5 is kind of the same idea. Is QS a diameter? And again, we're going to explain. So let's analyze what we have here. So I have a chord. It is perpendicular to the center. But you'll notice one half of the chord is 19, one half of the chord is 20. So my chord is perpendicular to the center, but it has not been bisected. So this is still that third property, but is QS a diameter? No, QS is not a diameter. Because even though it's perpendicular to the chord, it does not bisect the chord. Okay, moving on to the next example, example 6. We're trying to figure out Is LK, which is this little half of the chord here, congruent to the other part, KN? So again, let's analyze what we have. So I have a chord LN. It is perpendicular to the center. So chord is perpendicular to the center. So which of the three properties is this? It is that second property. What does the second property tell us? It tells us the chord is going to be bisected, which means split in half. So this chord will be split in half. So yes, LK will be congruent with KN. All right, let's take a look at example 7. We're trying to figure out, is arc ST congruent to arc RS? So again, let's just analyze what we have here. Okay, I have a chord, TR. I also have a diameter. I'll just highlight it in blue, SU. But you'll notice there's no perpendicular, there's no right angles between the two. Nothing's being bisected. We're really not given anything. We're just given a chord and a diameter, and they're intersecting at W. So since I'm not given anything, I can't use the second property. I can't use the third property. So we would just say we do not know. There's not enough info. Okay, example 8, we're trying to find the length of BD. So I'll just put a little X here. So again, let's analyze what we have. Okay, we have a chord. I've got a right angle, so I've got that perpendicular. So my chord, it is perpendicular to the center. So again, which of the three properties is this? This is property number 2. And what does that property tell us? The chord gets bisected. So that means the chord is being split in half. Well, notice that we're already given half of it's 5, so I know the other half is 5. So what is the total of X? It is going to be 10. So BD is 10. Okay, let's take a look at example 9. We're trying to find the measure of arc JK. Again, let's analyze what we have. Okay, I have a chord. I also know that it's perpendicular to the center. So which of the three properties is this? This is property 2 again, which tells us the chord gets bisected. So I'm going to draw little segments here. Okay. So let's also think back to property number 2. When the chord gets bisected, what also happens to the arcs? The arc gets bisected as well. So I can draw some more tick marks. Arc HJ will be the same as arc JK. So right away, there's our answer. The measure of arc JK will also be 55 degrees. Okay, last problem. We're going to find examples, find the measure of arc MN. Okay, again, let's analyze what we have. You'll notice it's kind of repetitive. You're usually given a chord. You're usually given that it's perpendicular to the center. So chord is perpendicular to center. So which property is that? That's the second property. But what does that property tell us? It tells us the chord is going to be bisected. So we can draw little tick marks here. The chord is being bisected. But also property 2 tells us that the arc will get bisected. This is just like the last example. So we can draw some more tick marks. So this is going to be the same. ML will be the same as LP. So even though we're not looking for it, it's good to know that ML is going to be 61. Now, how is that going to help us find MN? Well, there's one more thing that we have here in this circle. We have a diameter. So I know it's going to split this into 180. It's a semicircle. So we can use 180 minus the 61 arc on the bottom, and that will give us 119. So that is the measure of arc MN, 119. Okay, I know today's notes were a little bit lengthy. Thanks for watching, guys. Let me know if you have any questions. Have a good night.